lifting and holding, turning and pressing. Without compressed air, there's no holding or moving. This form of energy is a must for industrial production. The problem is 97% of the energy used to produce compressed air is lost as waste heat. That's why Technik, a company that makes machines for the automotive, medical, and solar energy sectors, uses a special device to produce this form of energy. A compressor draws in fresh air. Here, an electric-powered auger compacts the medium. The compression creates heat. But unlike normal compressors, this one doesn't let the heat go to waste. The heated air flows into a heat exchanger, providing warmth to the company's heating system. The compressed air is then conducted into a steel container, where it's available for production according to need. This air compressor uses about 70% of the electrical energy input, compared to only about 3% for compressors that use no waste heat. The southern German company uses compressed air to power tools such as pneumatic screwdrivers and grinding pencils, among others. Only with the help of compressed air do these instruments reach the necessary torque. Because of this and other uses, the fluid energy form is distributed through extensive pipelines in many companies. The problem is loss due to leakage. Technik uses a special ultrasound microphone to track down leaks. The mic detects exact sources of the sounds made by air seeping out of tiny holes, sounds that are inaudible to the human ear. That way, the tiniest leaks in pipes and joints can be quickly found and repaired. There are further simple measures that help minimize loss. In many companies, several air compression systems work independently of each other. A simple valve can be used to turn off parts that aren't used during late shifts, extra shifts, or on weekends. That also prevents further leakage from those parts. Technik not only uses the fleeting form of energy for machine production, the company also uses compressed air to power its own machines, and it's taken on an important function in the use of gripping systems. For the operation of special vacuum grippers, vacuum air is made from compressed air. To reach a high level of efficiency, the company uses an energy-efficient vacuum ejector in its machines. The compressed air flows over a so-called Venturi injector. Here, it's accelerated to the speed of ultrasound, pulling along the surrounding air. That creates underpressure in the adjacent part of the ejector. A sensor continuously measures the pressure. As soon as the necessary underpressure is reached, the vacuum can grip a component part, such as a solar cell. If the pressure continues to sink, the stream of compressed air is interrupted by a valve, and a stop valve seals the area with the underpressure airtight. The gripper can hold the component part as long as needed, without more air flowing over the Venturi injector. That saves energy. If the component is released, the valves open a direct path for the compressed air to reach the gripper. That allows precise control over the gripping process down to the exact millisecond. The use of efficient technology not only helps to save energy, it also increases the quality of production for lifting and holding, as well as turning and pressing.